It's time to get your brain back into the mode of limits. To help you out, we're going to just reintroduce it with a graphical look at limits, and we've chosen one crazy function, f of x be crazy, look at that thing, and we're just going to investigate the different regions and try to get your limit knowledge back on track as quickly as possible. Let's first look at this spot right here, which in limit language we're thinking about the limit as x approaches 0 because that x value is 0. What I'm thinking about is as I approach from either direction, what is the trend in the y values as my x is getting closer to 0? What's the trend in my y values as x is getting closer to 0? Let's put that into math language, and here it is. Limit as x approaches 0 from the right is 3, meaning my y values were getting closer to 3 as my x was getting closer to 0. Here's my left-hand limit. Because my left-hand limit was equal to my right-hand limit, I know that the limit at x equals 0, or as x approaches 0, is 3. The limit value is 3. Notice the actual function's value is 4, but in limits, you never care what happens exactly at the spot at x equals 0. You just care about the trend leading up to it. So there could be a monkey on a bicycle eating a Pop-Tart at x equals 0, and you would not care. You just care about the trend. And by the way, this is the official math language, but math slang is left-hand limit equals right-hand limit at x equals 0, thus the limit is 3. But you'd prefer to write this in an official math environment. Well, let's look at another location. Let's look at x equals 2. So just very informally, sneak up from the left. I'm closing in on a y value of 1. Sneak up on the right. I'm sneaking up on a y value of negative 2. If I were to put that into math language, the left-hand limit is 1, the right-hand limit is negative 2, so the limit does not exist because the left-hand limit does not equal the right-hand limit. We can look at a couple other locations. Look at this funny business happening here at x equals 2. Sorry, that's negative 2. As x approaches negative 2 from the right, my y values are blasting off to positive infinity. As I approach from the left, my y values are blasting off to negative infinity. So we would write this in math language, and then we would say the limit as x approaches, you know what? This is a negative 2, isn't it? Okay. As I approach negative 2 from the right, and as I approach negative 2 from the left, I'm getting different answers. So the limit as x approaches negative 2 of f of x does not exist, or that. And then let's do one more. Let's take a look at this. We're moving from a vertical asymptote to a horizontal asymptote. And at that horizontal asymptote, we can change that into math language by saying this. As my x values go out to infinity, my function f of x is approaching negative 4. And in a case like that, there's no left-hand limit or right-hand limit to think about. And that's that. So I'm trying to jostle your brain to get back into the idea of limits. And we'll follow this up with the mechanics of actually computing limits with equations and stuff like that. Welcome back to calculus.